Great. Well, welcome everyone today. I'm Devin Stops, and I'll be co-presenting with David McMillan on some of the City of Toronto's TransformTO initiatives and how these deal with buildings. So TransformTO, it's Toronto's ambitious climate action strategy to reduce greenhouse gas emissions and create a low carbon future for Toronto that's healthy, equitable, and prosperous for all. So this target's been accelerated over the course of this strategy, where we now have a new target of, as of last December, of net zero emissions before 2040. So very ambitious target and very exciting to be moving towards that. So out of the guiding principles, TransformTO, we want to focus on making sure that this strategy improves life for everyone. So I think it's critical to note while we touch on some aspects in more detail today, we're thinking about all of these aspects. So where did Toronto's emissions come from? So greenhouse gas emissions in our latest inventory, we see that buildings actually make up 57%. So most of Toronto's emissions, with the remainder from transportation and waste. So out of buildings, it's even more interesting to break down where this comes from in those sectors. So if you look at this, I always like to use this slide to point to the single family homes at 31% and the multi-unit residential buildings at 29%. So I always like to point to this as this is something everybody who lives in the city can touch, because over half of those emissions are from buildings that we live in. And inside of those buildings, it's broken down even further by fuel type. So most of those emissions, as you can see on the right, are from burning natural gas, and that's almost always in residential, commercial buildings. It's focused on space heating and water heating. We have cold winters, and we like to take hot showers. So that's something where there's an opportunity to do better. So I'll hand it over to David to talk about new buildings before coming back to existing buildings after.
Thanks, Evan. And just to note, there was a question that popped up in the chat. I think there was a question about what something stood for. I don't know if you saw it.
I see that now. So the MTCO2E is megatons of CO2 equivalent. So, we can dig into that deeper if you want, but just let me know. Send another question if you want to go deeper. Oh, yes, please. Okay. So CO2 is, we'd call one of the greenhouse gas, right? So CO2 helps hold heat in the atmosphere. Now, when you're looking at gases in the atmosphere, it's not just CO2 that helps hold heat in and cause this greenhouse effect. The other big one that's talked about currently is methane, right? And some of those fugitive methane emissions, because methane actually has a much higher global warming potential than CO2. So it's equivalent to much more than 1 unit of CO2. Same as other things like refrigerants in your air conditioner. They also have a global warming potential, and they'd have an equivalent value of CO2. So really, we just use this measure to make sure you're measuring in the same way across the board. Okay, David.
Thanks, Evan. Good morning, everybody. So today we're really going to dive in deep to new buildings here, given that the case study you're dealing with is, I think, for the most part, a redevelopment of an existing building. So there's a few key documents that really guide sort of our approach to new buildings in Toronto. which, as Devin pointed out, when breaking down the emissions, what he showed was all the existing buildings and what they produce. New buildings, obviously, much smaller fraction of that, but because they're new and because we have some control over them as a city corporation and as a regulator of the private sector, we have a very robust framework to require certain things. And so that starts with the 2017, the Zero Emissions Building Framework, which you see on the far left there. That's when Toronto really started getting quite serious about building performance. It's when we brought in absolute targets for energy use and emissions. And that's what really set the stage for the tiered framework out to 2030, which is the target for net zero buildings. And so that was a really sort of watershed moment in new building requirements in Toronto. And that accelerated further with the adoption of TransformTO, which Devin started, the net zero strategy specifically, which Devin mentioned at the beginning. And the acceleration of the already aggressive building targets to actually now achieve net zero by 2028. And so that's only 6 years away. So we're really trying to race to get to net zero buildings as quick as we can. And where we are right now on the far right is we're in version 4 of the Toronto Green Standard, which came into effect in May of this year. And basically going from version to version, so we were in version 3 since 2018. The next one will be 5 and then 6. As we go from each one version to the next, the performance requirements get more and more strict. And so that's important to understand because this is more for the industry, but as you ramp up performance requirements, you want it to be in a sort of predictable way so that the industry has time to adapt and build these requirements into their development cycle. So that's the framework that we have. Devin, if you want the next slide, please. And so this is a little more detail on what I just described. So I mentioned that we have these targets. In the past, energy performance was really based on sort of a reference building. So it's kind of like you have a base building design and you were a certain percent better in terms of energy performance. And that was really focused on energy use. With the Zero Emissions Building Framework in version 3 of the TGS, what we brought in as well were targets for thermal energy demand intensity. So that's the TEDI, which is really about the performance of your envelope and heat loss. And most importantly, GHGI targets. So that's your greenhouse gas intensity. I mean, our objective is really to reduce emissions, carbon. And so that's what the GHGI target is all about. And so those are two really important targets that we brought in with version 3 of the TGS in 2018. And also, as I said, and as you can see here in the image below, we're on a stepwise path to get to, well, near zero emissions by 2030. And that near zero really means it's not using any natural gas on site, but it does recognize that there is some carbon still in the electricity grid. And so it's not quite zero emissions, but you can get there or get to net zero either through on-site generation, procurements of off-site electricity, or offsets. Anyways, all that to say, the goal is to get as close to zero GHGI as possible. And this is the framework that is in place at the moment. Devin, next slide. But then it was accelerated just at the end of last year, as I said, when council adopted the net zero strategy. So basically our GHGI targets now in 2025, so it's been accelerated by 1 year for the next version of the TGS, version 5. And then the final version of the TGS, which is essentially net zero emissions, is now 2 years earlier. So in 2028, as I said. So we really have 6 years, less than 6 years to get to buildings that are fully electrified and use some renewable energy on site. Next slide. And it gets even harder for city buildings, which is what we're really talking about today, city-owned facilities like the St. Lawrence Center. Since basically at the start of this year, council said city buildings have to be net zero now. And it's important, and I can appreciate there's some nuance with these terms, but net zero is different from near zero. So city facilities have to actually achieve a GHGI of 0. So if you're a private sector developer and you're aiming for the highest tier of the TGS, technically you have to achieve a GHG of 5 kilograms of CO2 per square meter. If you're a city building, you have to get to zero. And that essentially means, as I said, 100% electric, no natural gas combustion on site, and maximizing renewable energy. Of course, built form really matters when we talk about how much renewable energy you can get on site. So again, there may have to be some discussion about offsite generation or procurement of credits of some sort. And you won't go into those details yet, but something for you to think about as you over the next few days in terms of what this means for the St. Lawrence Center. You do have to look at version 4 of the TGS, which is what we're in now, tier 3, that's the highest tier, plus some on-site generation if possible. Again, once you get into the design exercise, where could you put rooftop PV, for example, and how much of it? Is that enough to get you to an actual GHGI of 0? If not, what are the other solutions you use? For example, offsets, offsite generation, that's really up to you guys to figure out, but that's sort of the framework that guides performance for city buildings like this one. Next slide. So this is just, the next couple slides really are just some of the detail of what's required for city facilities in terms of what you actually have to achieve. So I did mention a GHGI of 0, but there are some other criteria. There are options essentially. Now, I think it's important you understand these. And obviously the choice to pursue one or the other, it really depends on the project. So I would say focus on the GHGI of 0, but keep in mind that there are some other requirements in terms of energy performance. And the path you choose may depend on the use of the building. The St. Lawrence Center is as a unique archetype. We don't have specific energy use intensity or thermal energy and demand intensity targets for this type of building. And so that's something that, when you work with the experts joining the bootcamp, they will be able to advise on. So I think it's important to understand that even though we have these paths, the city is flexible in terms of actual energy performance, but where we're strict with requirements is on carbon. So that GHGI of 0 is really important. But by all means, go through these during the bootcamp, listen to the experts, and think about what approach makes sense for a building like this. Next slide. So resilience is also an important part of city facilities. I'll get into it a little bit more later, but essentially, when it comes to new buildings, our narrow definition of resilience is to have backup power. Obviously our grid is pretty reliable in Toronto, but there are situations where there are area-wide outages. And the question is, what role can buildings play in supporting people, who are dealing with a power outage? Can they stay in their building? Is there a community hub nearby that they can visit as a place of respite? Obviously, it's not written here, but I think it's implicit that a really high-performing building, particularly the envelope, helps with resilience because it loses heat more slowly than one that is a poor envelope. But at the same time, there are certain things that only electricity can provide in terms of convenience. And so this is something that we take into consideration with the Toronto Green Standard as well. Next slide. And then this is really a new one, and I think you'll get into this as well in the bootcamp, but embodied carbon. So everything I've talked about so far is operational carbon or operational emissions. That's essentially the emissions from the use of the building, day to day, burning gas and consuming electricity. That generates direct emissions. But embodied emissions, there's a few different sort of names for it. You might hear upfront emissions or material emissions, but essentially it's the carbon associated with construction. It's with and even earlier than that, it's the manufacturing of the materials that you then use to construct a building. And really, it's actually about the whole life cycle of those materials. So it's a topic unto itself. So I think what's important for you to understand is that what you use to construct the building and the design of it has carbon implications. They are early in the project, they are upfront, and they can be quite significant, especially in a high-performing building, because you're not burning any gas, you're using very little electricity, you're using it efficiently, you're offsetting that with renewables. But those materials, whichever ones you choose and how much of them, there's a sort of a carbon content associated with them. There are ways to reduce that, and again, that's something I think the experts in your group will be able to help advise on, and I'll go through a couple of examples later. Next slide. So now I'm going to talk a little bit about sort of some of what we see for this building, and some of the things that I think you'll grapple with that we think you'll grapple with over the next few days. So the first one I'll go into next is embodied carbon. And before going to the next slide, just to point out, like, this is an existing building, right? All of that carbon, those CO2 emissions are already in the atmosphere, right? And I would suspect there's quite a bit of them. So when you look at the existing St. Lawrence Center, it's a lot of concrete. It's, burlesque building from the 60s. This was a style at the time, and there's a lot of concrete in this building. And so I think it's important to be conscious of embodied carbon, considering we're talking about a redevelopment of this site. There'll also be, the heating and cooling source is really important. Again, that's where a lot of the emissions come from, as Devin pointed out at the beginning. And then, of course, there's a few other issues that are equally important that we'll get into as well. Next slide. So embodied carbon. So as I said, we're demolishing a building in large part. And so I think it's really important you're aware of, first of all, how do we minimize the embodied carbon of the new building? And there are strategies to do that. But then how can you, if at all possible, reduce the carbon deficit? And this is just sort of, this you may not find written down anywhere, but if you think about it, we've started at a deficit because all of those emissions, as I said, they're already in the atmosphere. And so to truly be, get to net zero emissions, be zero carbon, I think it's important to consider the whole life cycle of a building and that we're not making the problem worse and ideally trying to make it better. And so some of what that means is, first of all, avoiding carbon intensive materials from the get-go. So let's not make the problem worse. So I've just listed a few here that we see as common culprits in new buildings. You want to minimize the use of concrete and steel. XPS spray foam, that's just extruded polystyrene spray foam. It's very common product. It's very good at what it's meant to do in terms of insulation and airtightness. But some of the expansion materials that are used in the product, they're very high global warming potential. And then aluminum is just another very common product, particularly in cladding and window frames. Generally speaking, very high carbon content, or carbon associated with this manufacture, I should say. Then, of course, the envelope. So, the envelope is a huge part of besides the structure, the envelope is a huge part of the embodied carbon story. But of course, this is where, I won't go into any detail. I think it's going to come up a lot in your discussion. There's an important balance between aesthetics, energy performance, and then embodied carbon. And so that's something to keep in mind as you do your work. And then, of course, maybe the most controversial one is when we talk about biogenic materials. And this is where we get into the discussion of life cycle. And if you can actually start to reduce that deficit that we started with. So biogenic materials like wood and straw, they can actually technically sequester carbon because as they grow, they absorb carbon. And so using them in a building is perhaps a way to start to bring down that actual deficit that we started with. Now, the key there, and that's why I put a question, is that you have to plan for end of life. Because if you just landfill that timber, for example, then of course it will release that carbon over time as it decomposes. So something to think about as you think about the whole life cycle of this building is you have to plan for end of life if you're going to think about carbon sequestration of structure, for example. Next slide. So a little bit more on embodied carbon, and I put in timber here, and there's actually a really good precedent in Ottawa. It's the National Arts Center, where this is a Diamond Schmidt project. They, this is more of they call it a rejuvenation. It's really a deep retrofit and modernization of an older performing arts building. And they, a lot of the structure and a lot of the new material was timber. And so there is a precedent for mass timber use in performing arts facilities. And mass timber, by the way, is just engineered heavy timber. There's cross-laminated timber, glulam, or some of the common materials that will be used. The bottom line is it's made out of wood, which is a biogenic material. And so there are benefits to it in terms of embodied carbon compared to concrete and steel. But this is a performing arts facility. So I think as you talk to the experts, I'm not one of them in this field, but acoustics, sound transmission, Those kind of things are going to be really important. They're important in a residential building when you're using wood, just because it's more conductive than concrete to sound. So something you're going to have to pay particular attention to. Glazing, as I mentioned, the envelope is an important one. So with glazing, sometimes less is more. Hint, hint. So what is an appropriate window-to-wall ratio for a performing arts center? Obviously, it's a cultural and civic hub. I mean, it's one of those things that you want people to notice when they walk by. You want it to be transparent. So you want glazing, of course. And I know the existing building, a lot of the frontage on Front Street is transparent, is glazed. And you want lots of light in these types of facilities for the public. So of course there's going to be glazing. The question is, where is it? Can you bring it down to a point that really helps with your envelope performance? Because as good as triple pane, triple glazed windows can be, they will lose more heat than an opaque wall. And then the discussion of triple versus double panes. Again, I bring this up because there's an embodied carbon, content to glass. And so that extra pane, is it worth the energy performance given that there's going to be more embodied carbon content? So these are things you're going to have to grapple with as you think about the energy performance of the building and what your objectives are. And then the opaque wall, of course, which is the parts that are not transparent, right? There are lots of options there, but I think probably what's most important here is you want something that is durable with a long life, that balances the embodied carbon, but that also has an aesthetic value. I don't have a picture of it here, but this is a brutalist 1960s building next to century-old brick buildings that were probably old warehouses and storefronts at some point. I think there's going to be some design choices in terms of what material you use to reflect that context. And so each of those design choices, should be balanced with carbon and energy performance as well. Next slide. So heating and cooling, and I think this deserves, this is an important slide because really we're talking about electrification, but all that means is that what's doing the work to provide the heating is a heat pump. So it's, a heat pump powered by electricity, right? The question is, in terms of the heating and cooling source, there are several options. And so I'll just go through them quickly, and this is very high level, but again, you'll have the experts over the next few days to talk about what's most appropriate for the St. Lawrence Center. Air source heat pumps, very common technology, generally a lower capital cost, but higher operating costs, because of course, air doesn't have as much energy in a cold climate like ours during the heating season. So you can use a bit more electricity, so the cost can be a bit higher to operate them. And something to consider if you're thinking about air source heat pumps is you need somewhere to locate the condenser units, and that's typically on a rooftop. And I don't know what the plan is exactly here, but if you want something else for that rooftop space, you have to find a way to balance that. Geo exchange or ground source heat pumps. That's using the earth as essentially a battery. It's warmer than the air all year round, so it has lower operating costs, but you have to drill bore fields essentially, to get that heating and to use it for cooling. So it's all below grade, which is great, but again, the capital costs are a bit higher. Wastewater, this is maybe a newer one for some of you. It's probably got the highest capital cost, but again, the lowest operating cost because, wastewater is 18 to 20 plus degrees almost all year round. So it, it's very warm essentially. Now you need space for that infrastructure as well. It can be below grade, but it can be very large. So it's something to keep in mind. And then district energy or thermal network. We're downtown, so I think the obvious consideration is Enwave, the big provider. It's only about, based on my measurements, 150 to 200 meters away over at Brookfield Place, and that's the deep lake water cooling pipe. I ignored steam because that's likely not going to be feasible given the performance objectives for this building. So something to consider as well. With geo-exchange and sewer heat and district energy, this is often provided by third-party companies, and they have a business model that can really help reduce those capital costs. Something to keep in mind is not just that St. Lawrence Center doesn't have to be an island. There can be partnerships with these energy developers to be energy providers on long-term contracts that can help with the upfront costs. Next slide. So this is, I wanted to dive a little bit deeper into wastewater energy because, again, you may not have heard about it. It's fairly new for us in Toronto. We have one project under construction right now, but this is important because you can see by this map, there's a lot of heat available across the city. And so again, this is a citywide map of our trunk sewers. These are just the largest ones. There's a lot of heat available to use to displace natural gas from buildings, which, as Devin said, is our main culprit in Toronto. So you can, this is just what our internal website looks like. And at the top there, you can see just in the address bar, if I was to do a demo, that's where I would type in the actual address of the building, which I'll show on the next slide. This is St. Lawrence Center here, 27 Front Street East. And just as luck would have it, you're surrounded by very large trunk sewers. And so, you know, like with any sort of project with infrastructure, you want to minimize distance between sort of source and sink. And, you know, here it's running by your doorstep on Front Street, and it happens to be a very large trunk sewer as well. So I think, I can't see on the screen now, but I think there's close to 9 megawatts of heat there. This is, you know, a lot of heat, probably more than enough for this building on its own, for other buildings in the area as well. So the bottom line is, I think it's worth to consider, you know, this as a potential low carbon heat source. Next slide.
Dave, we've got a question about what the blue versus orange line on this means.
Oh, I think on the previous slide, Devin, the blue are just I think they're the ward boundaries or maybe the neighborhood boundaries. Those are the wards, I believe. Yeah,
I think it's the one on Front Street there, right? There's a blue section. I'm assuming it's lower heat.
So that's just, sorry about that. When you click on the section of trunk sewer, it pulls up that section there. So basically it tells you, so if I was doing this live, if I were to click on a different section, that section would then turn blue. It's only basically pulling up the stats in terms of flow and temperature for that section that you click on. That's why it's just highlighted blue. It doesn't mean anything. Yeah.
Got it.
Yeah. Okay, perfect. Thank you for the question. Next slide. So I'll just quickly, there's a few other things to consider as you work on the St. Lawrence Center project. So I mentioned rooftop solar photovoltaics at the beginning. That's we see that a lot in Toronto as a way to sort of offset some of the electricity that you use from the grid. But I mean, we're downtown here, right? So the question is, you know, what about shading? What about the green roof? There's obviously a plan for a green roof here, and they can coexist, but you know, it has to be done in a certain, it has to be done with careful planning. The commercial kitchen, and maybe Devin, I don't want to be in the spot. I don't know if something you want to talk about. We recently toured a new passive house student residence at University of Toronto Scarborough with a fully electric commercial kitchen, which is very uncommon. But if this building has a commercial kitchen, that's going to be a really important thing to think about to actually achieve sort of the zero carbon goal. Devin, do you want to add anything on that?
Yeah, I mean, I'd point to some resources. So I believe there's a great paper out of Sweden from 15 years ago where they looked at the energy use in an all electric kitchen versus not. So this is something I think we're just lagging a little behind, but you know, the possibility to run an all electric commercial kitchen is definitely there, especially looking at technologies like induction stoves as well that are much more efficient. And, you know, pretty much every device. So I know when we were talking to the U of T folks, they were pointing to the pizza ovens, right? Electric pizza ovens, fairly uncommon. But again, you know, the results apparently were very good when they looked at what they could put in. So it's possible. I think the biggest thing is it's usually a little bit more expensive. But from my memory of that paper as well, actually operating it usually doesn't make a huge difference in operating costs.
Oh, thanks, Devin. Yeah, so then the one other thing to pay attention to, we talked about the goal of resilience. The St. Lawrence Center, you know, it's meant to be a cultural and civic hub. That has, you know, can be interpreted differently, but maybe one to consider is Does that mean the St. Lawrence Center should be able to house people, or not house, to be a temporary place of refuge for people displaced by power outages? You're right downtown, there's a lot of tall buildings. A lot of those buildings were not designed to keep people in them during an area-wide power outage. St. Lawrence Center could provide that function if there are spaces to do that. It requires some planning, but for your purposes, I think it's important to think about what are the options for backup power. Do you have to have a gas generator? Could you do this with solar and storage? If you're looking at solar and storage, where do you put this equipment? A battery in the basement, or if it has to be a generator, it's likely on the rooftop. And again, that rooftop space is a premium. So do you want to have a gas generator up there? So not trying to be prescriptive, but just telling you there are objectives that the city sets, and it's important for you to think about how you might achieve them. Next slide, Devin. And I think this is my last one. I just want, so my colleague normally from environmental planning would be here to talk about this. They couldn't make it, so I'll just quickly tell you about it. I won't be able to answer a lot of questions on it, but I think it's important for your knowledge that there are other requirements in the TGS that have nothing to do with energy. Well, they're not specific to energy and carbon. There are a couple of areas where they overlap, but these are just at a high level. If you click on the reasons at the end, you can go into their detail, but this is just at a high level, some of the other non-energy and carbon elements. I don't know that there'll be any parking here. If there is, we have EV readiness requirements. So that's something for you to consider as you think about serving this site electrically. Managing water is a big part of the green standard. Again, if I highlighted stormwater management because the green roof is going to be, I think, an important way to do that on this site. There's not a lot of open space. And so if we go with something like solar or something that's, otherwise hard surface, you lose some of that ability. So these are just some of the challenges that you need to, and trade-offs that you need to think about as you go forward. Next slide, Devin. And I think it's back to you.
All right, great. Thanks so much, David. So I wanted to start talking about existing buildings. So my group helps existing buildings with guidance on how to get towards net zero or how to build a better project. We also work on financing for some of those projects to enable those. And we're rolling out a few other programs as well. I wasn't going to focus on this slide too much, but these are some of the programs we run for existing buildings out of the city. So one of the key things is our emissions strategy for existing buildings. So this strategy we put together to hit a 2050 target, and we're currently updating to hit the 2040 target. But the actions out of this remain the same, more or less, but faster. So I'm going to touch on a little bit today the technical analysis and modeling that went into this, the recommended actions that came out of it, and the high-level idea of how to implement, which hopefully will help contribute to your project. So we were looking at, balancing those. How do you retrofit the entire building stock in Toronto and balance greenhouse gas emissions reductions with the costs of retrofitting all of the buildings in Toronto? And so I think a big part of that we'll get into further is the co-benefits. So, you save energy in doing these retrofits, but you also, as David pointed out as well, you also improve the resilience, the ability to ride through a power outage. You improve the health of everybody from lowered emissions. You improve occupant comfort, in terms of better thermal or less noise. And this can be used to drive, equitable solutions and lots of green jobs in the city as well. So key findings for existing buildings. So it is possible with our current technology to retrofit to 80% plus emissions reductions across all buildings in Toronto. So getting all the way to net zero is not technically or financially feasible just doing building retrofits, you need to be able to offset that remaining fossil embodied carbon or operational carbon, or have some other measures. So the two key things to actually getting to high performance, which is really, really critical, is fuel switching off of natural gas to clean electric heat pumps and clean electrical system. So our electrical grid in Ontario has relatively low emissions, especially compared to other grids in the world. And while this will increase over the next decades with the phase out of some of our nuclear generation, and just meaning that that peak loads are provided more by gas plants potentially, you still have relatively low emissions with a lot of Ontario's power coming from nuclear, hydropower, there's some wind in the mix, and some solar. But we need to keep driving to clean up the electricity system further to enable us to decarbonize. So really important to note too, you have no pathway to decarbonize if you're burning fossil fuel. If you're using electricity for your heating systems, you do have a pathway because it can be fed with dirtier electricity or cleaner electricity. So there's only a pathway when you're on a system like an electric system. So the one other thing to touch on, I think, is renewable natural gas. We have an achievable potential study done for Ontario by the regulator, which shows that even if we captured all of the food waste, all of the organics that we could be used to create renewable natural gas in Ontario, you could only offset about 10% of our gas use. So, it's not a pathway to just say renewable natural gas is a path to just offset our carbon use. Can't be done. Very similarly with hydrogen, you have to remember that hydrogen, clean hydrogen, green hydrogen is produced from electricity, electrolyzing water, and gray or blue hydrogen is produced from natural gas. So you still have a carbon component of that, it's not a be all and end all solution. So back to buildings. So key findings out of this, we need to upgrade the envelopes of buildings. So that's the insulation, the windows, the air sealing, the doors. So this needs to be done to help keep the peak demands lower. So that coldest day, you want to be able to keep your heating load lower. This helps save system costs on the electricity system, which is a huge component as well. Avoided building more generation that way as well. So building retrofits are a significant net investment for building owners. There is not a payback to going net zero. And so the city also is looking at how do we make these measures mandatory. So we're going to be, in order to get to net zero, we need to actually require, similar to TGS that David was talking about, we need requirements for existing buildings when they retrofit. So the actual results from the strategy, so we figure we can reduce sector-wide emissions by 82% across the city. This is all private buildings and publicly owned buildings, all buildings in Toronto, right? And this is a huge economic stimulus for the city as well. You're basically doubling the amount of retrofit that is done over this period of time, increasing from 162 billion that would have been spent on building retrofits in this next 30 years to 300 billion. So that's the opportunity to create a lot of new green workforce and supply chain. And that's a great way to drive some more growth in Toronto. So the co-benefits, here's, it's just a few examples. And I think I touched on these before, that improved comfort is a huge part of this, improved document health, improved resilience. And there is the potential to lower energy costs. I'm pointing to right now in August, the cost of gas, natural gas, has just gone up about 30%. So that will translate to higher heating bills this winter. And it's very interesting, but electric heat starts to have, through heat pumps, starts to have a significant advantage. So out of this strategy, what are we looking to do with existing buildings? We're looking to set requirements and assess current building performance. So we want to be able to get the data from buildings. How do they operate now? How much energy do they use? And out of this, we'll be establishing requirements, saying, similar to the TGS requirements David was talking about, we'll have requirements for existing buildings. So there's other jurisdictions that do this now. And, it's a pretty cutting edge thing, I'd say, which will be very interesting to see how some of this shapes up. Then we're also looking at, to enable this, we need to provide this integrated retrofit support. So, like this process you're going through with the St. Lawrence Center, we need to be able to convene those experts and be able to say, how do you get there? What technologies do you use? How do you deal with building specific problems? And, the people in charge of most buildings, either, building owners, operators, they don't always have the background to know how they should retrofit. So we need that roadmap to how do you get to where you want to go. The other big part of that is financing. These projects are expensive. They don't necessarily have a payback. So how do you pay for it? And a lot of that likely will come from support of different levels of government and providing enabling financing. One of the examples for single family homes right now is the Greener Homes grant and loan program. Great example of some good action. And as people move to do these projects, we're going to support through that permitting and approval process. How do you get there? How do you get an exemption as needed? Or how do you use technology that's not commonly used? So early adopters often struggle with enabling some of these things, and we want to assist with that. And the city's also going to be looking to build awareness of how do you decarbonize, what's net zero, again, expand supply chain and workforce, and advocate to other levels of government for action. So we're talking about how do we plan for this right now, transitioning probably from voluntary first to mandatory over time. We're scaling up our programs that I mentioned at the start. So our retrofit supports, our loan programs, and yeah, I mean, it's a very exciting time to be in this space. I'm gonna touch on this. I've reused these slides, and one of the initiatives we're in the process of launching and will be launched in the next few days is a deep retrofit challenge to drive more development of deep retrofit projects. So really I'm highlighting this because of this second line on here, where talking about deep energy retrofits, we're talking about a significant energy reduction. And I think that's something that's really important to keep in mind. I think you're going to hear from other experts as well, but it's that significant energy reduction in the building that's very critical in order to make these projects economic. So improving the envelope. a deep retrofit. So when you talk about deep retrofits, you're talking about all of the building systems, how they interact, and how do you use energy from one place to preheat, cold water coming into your, waste heat to preheat cold water coming into your water heating system, or how does your ventilation system interact, to remove that waste heat again from kitchen exhaust to preheat cold winter air coming in. So key things, again, I'm going to always come back and reiterate these points. The building envelope, right? The insulation, the windows, the doors, how airtight it is, critical to managing that peak load. Critical part of fuel switching off fossil gas, off fossil fuel natural gas to electric heat pumps, be it ground source, air source, wastewater source, could be anything, but that switch to electricity is critical, right? And then you have to consider all of the other aspects of the building, how they interact, from operations and occupants to building controls that decide when something's turned on or when to turn it off, and then finally integrating renewable energy to offset that last bit of carbon intense energy used. Right, here's the examples. I talked about these already. I should have been on the next slide, I guess. And this is another critical part that I just thought I'd mention as well before we get to wrapping up. So efficiency. Efficiency, when you think about a gas furnace, it might be rated for 96% efficiency. Because of turning on and off, heating up, it's going to be a little bit lower. So you think in that 80% range, okay, that's not too bad efficiency. You think about now an electric resistance heater, like a baseboard heater. Anytime you have electric resistance, it's basically 100% efficient. So, doing well in terms of efficiency, although electricity typically has costed more, so it's still more costly to run. Now, when you get into heat pumps, you're looking at something that's at least 300% efficient. So you're getting to use a lot less energy with heating with a 300% heat pump than an 86% efficient gas furnace, right? So that can help bridge the cost barrier between those systems. Looking at something like ground source that David mentioned, it can be even more efficient than air source, just because of that energy in the ground. The higher temperature through the winter can help it be more efficient, right? So I'm not going to talk about this one too much. Again, just a reminder that there's no simple payback on doing these projects. So, I think you're going to struggle with the economics of these projects, but that doesn't mean that there isn't a future case for something like this. I think, in a time of increasing carbon pricing, that can really help enable these projects. Increasing cost of fossil fuels, we're seeing it with natural gas and with gasoline, that costs have increased recently significantly. And something like that can help shift the balance to make heating with electricity more cost effective, right? So to actually get where we need to go, basically most buildings, except for some of the newest buildings, all buildings in Toronto are going to need windows, insulation, air sealing. Even those newest buildings that David was talking about, those buildings that are being built to the highest tiers of TGS today are still often installing some sort of fossil fuel heating equipment. That's going to need to go. So the version of TGS that comes in 2028 basically requires that to go. But up until that point, all of those buildings are going to have to replace the systems they installed with something with electric heat pumps again. And yeah, this is reiterating a bit of the same thing again, where I just love saying this. We need to move from the fossil fuels to electric heat pumps. You know, and it's possible then to meet our net zero targets. Very ambitious to do it by 2040, but with action now, there is hope to get you know, a large portion of the way there. So I'm going to skip through this as well. We have these resources links we'll make available at the end, but really appreciate having the time to chat with you guys today, and happy to open up the floor to some questions. Okay, so I see one in the chat from Brianne. Hi, Devin and David. Your presentation was very interesting and full of valuable information. Would you be willing to share a copy of the presentation with the group so we can reference the information later? I think we're happy to share this. And I point to as well in those references, I think in those references, we have a copy of the TransformTO net zero strategy. I see David has, I will add to this before we send it out. We also have our net zero existing building strategy, which talks in more detail about those retrofit pathways. So certainly we can share some of this. Okay, I see also John Robinson. Is our case study project not a retrofit project? So do the TGS requirements that David outlined apply? Yeah, so I believe this project is, I don't think there's a new development portion of it. So those requirements don't specifically apply. However, the city's mandate to go net zero, you know, in terms of building retrofits, I believe that does apply. So I do think that these still need to meet, or this project still needs to meet that similar level of requirements. Right, that's the David, help me out with this. You remember the cities our internal strategies called the zero emissions.
The portfolio, the zero carbon portfolio plan. Yeah, it's
zero carbon portfolio plan.
So I think what would trigger the Toronto Green Standard requirements, you know, basically in terms of what is considered new development and not, it really depends if a new site plan application is required for this project. Like, and it's hard to say at this point whether or not that will be the case, because there's a lot of, you know, it's very uncertain at this point, but there's also a lot of judgment that goes into determining at what point a deep retrofit becomes a new build on paper. And that's a building code or building department's determination. But the bottom line is if it goes through site plan, it will trigger the new Toronto Green Standard requirements. And, you know, beyond that, though, it's still a city facility. And so we set the objectives even higher. So as so it's not, the pathway is, there's a bit of nuance, but the goals are the same in terms of the performance that we want to achieve.
Okay. I see there's another question for you as well from Robin. For TGS, what is the low carbon pathway? What is the incentive / requirement for meeting it?
So for city buildings, you know, there is no incentive. It's just a mandate from city council that we're going to be net zero now. And again, there's no incentive that comes with that. City council has essentially said, this is a requirement, and the project managers for the site will have to go back to council and say, this is the cost of doing that. Obviously, we want to be smart with how we do it. So if you design from the beginning to achieve net zero, hopefully you can bring down that capital cost premium just through integrated design. Now, if you're a developer, a private developer, going for the highest tiers of the TGS, or basically if you're going for tier 2 or better, there is an incentive, which is the development charge refund. And those recently were increased. So basically you get a small portion of your development charges back if you achieve and are certified to meet those higher tiers of the TGS. Yeah.
Okay. I see also, I'll try to answer this really quickly. There's a question on, have you noticed ductwork issues when installing ducted heat pumps in existing homes? So I would say, so here's the technical background. Heat pumps usually provide heat at a lower temperature than a gas furnace. So you might need more air volume to move the same amount of heat. So it can be an issue, and I'd say you really have to size look at your duct sizing for each individual home. That being said, if you also make improvements to the envelope at the same time, there's a good chance you won't have to upgrade any ductwork. You know, because adding insulation, better windows, that lets you lower your heat load, and then your existing ducts are very likely sufficient. So, you know, I suspect it's not a problem in as many homes as we think. You know, that's a common, I think, misconception, because people don't think of it paired with adding insulation. And also a lot of heating systems for homes are already oversized, you know, as a conservative choice when installing a system. All right, next question I see is, has there been a carbon study done on the impact of these new buildings replacing their HVAC systems in a few years? Would it be better to let the equipment run its lifespan, or is the current strategy better? Yeah, so the strategy we have actually does consider replacing HVAC systems at the end of life or close to the end of life. So it is, you know, when we were setting that 2050 target, originally the 2050 target, this was to incorporate, you know, you need to give buildings that time when the equipment needs to be replaced, to replace it with the better option. So, you know, I envision that's still mostly what will happen with newer buildings installing HVAC now. But obviously we've moved the schedule up 10 years, so it's a little bit tougher. And, you know, that embodied carbon question is a really, really critical thing to keep asking. So I think there's some further work that can be done on that, especially when, you know, updating our strategy for 2040. But I'd say in general, you want to replace at the end of life. So what role does the Ontario Building Code play in accelerating / slowing down meeting the goals of TransformTO? David, do you want to talk about that?
Sure. So, yeah, well, look, my blunt assessment is that the OBC is not helping us right now in Toronto for new buildings. The model national energy codes that were brought in federally, you know, the province is going to harmonize them with them by 2025, but they're choosing to harmonize with sort of basically the lowest options. And what it means in Ontario is that the performance requirements are really not changing for the next few years. So in Toronto and in other municipalities who have green standards, that's going to be what leads, not the building code. It can do better, but that's not currently in the cards. So I don't know, Devin, if you want to add anything there, but that's my blunt assessment of Ontario building code at the moment. Okay.
I think I'd love to just try to get to the last question before we
guys, I'm so sorry, but the live session stream has ended. Unfortunately, with this mechanical system, it just cuts things off. It is a coffee break chat, so I do see that you still have students on in here. I want to let the students know that if you'd like to move to the coffee chat just to have some informal chat, please feel free to do so. And Devin and David, if you guys are willing to stay on, we of course are thrilled to listen. This has been a fabulous talk.
Absolutely,
Yeah.
happy to. Thank you.
I'm glad. Thank you very much. And yeah, I mean, I would love if, you know, just for one more minute, because I think the last question's a really great one as well and really important to go back to. So the question's about switching from fossil fuels to electricity. And Melina's heard that electricity is expensive in Ontario and maybe not that affordable to switch from fossil fuels to electricity. And is this correct? And if yes, how can we explain the benefits of switching when electricity is not affordable, especially in residential buildings? So I'd actually say that's no longer correct. So, you know, we're right at this transition point. So if you remember, I was talking about these efficiencies. So, you know, you have a gas boiler that's 80% efficient and a heat pump that could replace it at 300% efficiency. So that actually means that it's very similar costs to heat your building with a heat pump that's electric or with a natural gas boiler. So the actual running cost is not very different. And there's a couple other factors like what your incremental cost of electricity is that also helps drive it. So I'll give you the example of, you know, tiered electricity rates. If you're paying in a residential building 11.5 cents for your incremental electricity use, the higher portion of you know, your bill on average is probably, you know, 17 cents, but that includes delivery and other costs. Then when you look at just adding extra consumption, your marginal cost is lower. So it can actually be a little bit more cost effective than you think when you do a detailed analysis. The other part of that is, you know, carbon pricing is still increasing. So every year, the $15 per ton increase in carbon tax till 2030 increases the cost of natural gas about 3 cents per cubic meter. So, you know, I think it's completely, you know, really similar cost, maybe even a little more cost effective to run an electric heat pump now, that business case only gets better over the next few years. So I think it's really important to address that misconception, right? That stereotype about electricity being more expensive is all from running electric resistance heat in you know, in towers built in the 70s that used all electric heat, basically, right? Electrically heated homes that use electric resistance. With heat pumps, operating it is not as expensive, right? Yeah. Cool. Well, I think we're out of questions. We had a lot of people drop off to the coffee chat, so I'm going to stop sharing. And again, thanks so much.
Thank you guys so much for taking the time. That was amazing. Absolutely fabulous. Really appreciate it.
Yeah, thanks.